I'll now finish up going over the test review by covering problems 16 through 23. Number 16 asks us to convert from exponential to radical form. Recall that a to the m over n is the same as the nth root of a to the m, where your denominator is your index. So my denominator of my rational exponent is my index. If I have a quantity like parentheses around this raised to the fourth, if I do not put the whole 5x in parentheses, it will be wrong, because then only the x would be raised to the fourth power instead of the 5 and the x. So make sure you put parentheses. If this has parentheses, make sure this has parentheses. And that's it. That's all you're asked to do is rewrite it in radical form. For number 17, I have 4a to the 1/4. Again, my denominator is my index, so this is the fourth root of 4a. Put parentheses just to be safe, although this is to the understood first power. For 18, you're asked to convert from radical to exponential form. We have an understood exponent of 1 here for our b, so this is b to the 1/5 power. For 19, we have an understood index of 2. Keep your parentheses, 3x to the 3/2, because your index goes in your denominator of your rational exponent. For 20, be careful. This does not have parentheses around it, but you should put these in, because when you rewrite this, you want it to be 6x all to the 1/2 power. If you leave off the parentheses and just write 6x to the 1/2, then only the x is to the 1/2 power. So don't do that. Make sure you add in a set of parentheses yourself. Next, we are taking the cube root of a quantity to the 8th power. Remember that this is the quantity 2x minus 4 repeated 8 times. If I can write it out 8 times and group them in groups of 3, you're welcome to do that. Instead, I will divide my 8 by 3. 8 divided by 3, 3 goes into 8 2 times with 2 left over. So you have 2 that come out. So that means you'll have the quantity 2x minus 4 twice. And then you have to keep your cube root, and you have a remainder of 2, which means you have two quantities of 2x minus 4 left over. If you have trouble seeing that, I'll do this up here. And this is going to be long, but I have 2x minus 4 8 times. That's 1, 2, 3, 4, 5, 6, 7, 8. So because my index is 3, I'm looking for groups of 3. So here's a group, that's going to come out. Here's a group, that's going to come out. That's why I have 2 quantities on the outside with 2 left on the inside. So that's to illustrate what it means, but you can certainly divide the exponent by the index. So this is the whole answer. Next, for 22, this is a 5th root. So we can start off by doing our factor ladder, dividing by 2 because it's even. That gives us 32, which is also even. Oh. Divide by 2, I get 16. Divide by 2, I get 8. Divide by 2, I get 4. Divide by 2, I get 2. And I'll stop because now I'm prime. I want 5th roots. That means I want a group of 5 of the same factors. So that means I have a 2 come out. Now, mind you, if you want, you can write out 6 m's and 15 n's and then group them in groups of 5. I am simply going to recognize that if I divide 6 by 5, that it goes in 1 time with 1 left over. So far left over, I have this 2. I have an m left over. And if I divide 15 by 5, I get 3, which tells me I'll get 3 groups of n's. And I'm through. So 2mn cubed times the 5th root of 2m. Next, for 23, I have the fourth root of x cubed y squared times the cube root of x to the fourth y to the fifth. We have to convert these to rational exponents to be able to simplify this. So we're going to have an x and a y, both to fraction powers, remembering that your index is always your denominator. So this will be x to the 3/4, y to the 2/4 times, and likewise for here, I'll have an x and a y with rational exponents, with this time an index of 3. So this will be 4/3 and 5/3. Now when I'm multiplying x's, I have to add their exponents. So 3/4 plus 4/3. Use your calculator for that if you like. 9, 25/12. So that's x to the 25/12. I'm doing this in my head. And y 2/4 plus 5/3. That is 6 plus 20 over 12. 26 over 12 reduces to 13 over 6. So y to the 13/6. Yep. And that's all there is to it. All right, good luck on your test tomorrow.